Alright, hi everybody and welcome to today's video. In this video we're going to look about how to identify the types of intermolecular bonding present in a molecule, comparing the strength of the different types of intermolecular bonds and relating that back to physical properties such as melting point and occasionally solubility. We're also going to look at the sorts of exam questions you might get on this and how you would go about structuring your answer. Okay, so first off, to figure out what sort of bonding is present, you can start with a flowchart, and I like flowcharts, as you might have guessed by now. So the first thing you need to ask yourself is the compound a molecule? Because if it's ionic or metallic, then you can throw that right out the window and start again with something different. Okay, so assuming that it's molecular, then the next question you need to ask yourself is it polar? Does it have polar bonds, and do they cancel out? If it is not polar, then the only type of intermolecular bonding present is your temporary dipole-dipole attractions. If it is polar, then the next thing you need to ask yourself is, does it contain HF, HO, or HN bonds? If the answer is no, then it will have both temporary and permanent dipoles. If the answer is yes, then it will have temporary and permanent dipoles and hydrogen bonds. Okay, you must mention all of the types of bonding that are present. That is really required. So let's have a look at an exam question so you can see the sorts of things. And this type of table, this is out of the 2018 exam, is very, very common. So in this particular table, you've got 3 molecules, and you know they're all molecules because it states that. You've been given the enthalpy of vaporization, which is basically the boiling point energy, the energy required to boil it, and I'll talk a bit more about that later. And you've been given the molar mass. So the first question is the attractive forces. So if we look first at methanol, we can go through that flow chart. So let's have a look. If we have a look at methanol, then is it a molecule? Yeah. Is it polar? Sure is. Does it have HF, HO, or HN bonds? Yes, it does, because it's got an OH in there. Therefore, it will have temporary and permanent dipole-dipole attractions and hydrogen bonds. So it's got all 3 types of intermolecular bonding there. If we look at the next molecule, propanol is actually exactly the same as methanol. It's got temporary and permanent. It's a polar molecule, it's got OH. If we look at propanal, okay, it's an aldehyde. So again, if we ask ourselves these same questions, is it a molecule? Yes, it is. We know it's a molecule because we're told it's a molecule at the start of the question. Is it polar? Well, it's got that carbon-oxygen double bond. That carbon-oxygen double bond is polar, so yes, it is. Does it contain HF, HO, or HN bonds? No, it does not. Therefore, it has both temporary and permanent dipole attractions, but no hydrogen bonds. Okay, so that's a table like this turns up in virtually every exam question. It's usually a fairly simple achieved point. Interpreting that and interpreting the other information is where it really comes interesting. Okay, so then we need to look at these pieces of information. If we just have a quick look at this table for a sec. If you look at the enthalpy of vaporization column, that's the second column here. Okay, it's this column here. We have a look at this. What we see is that the highest number is propanol, the next number is methanol, and the smallest number is propanal. Okay, now this is the energy required to boil it, which is pretty much equivalent to the boiling point. So you could say propanol is most likely to have the highest boiling point, followed by methanol, followed by propanal. Okay, that's just, I want you to keep that in mind for a sec, because we'll come back to it. Okay, now, strength of bonds. Okay, key things is that the molecules of the strongest intermolecular bonds are going to have the highest melting or boiling points, or the highest enthalpies of vaporization or fusion, which is the melting equivalent. So those ones with the highest enthalpies are probably the strongest intermolecular bonds. Keep that one in mind. The other things to be aware of is that all molecules still have temporary dipole-dipole attractions. The larger the molecule, the larger the electron cloud, then the stronger those temporary dipole-dipole forces will be. When molecules are about the same size, the relative strength of the bonds is that hydrogen bonding is the strongest, followed by permanent dipoles, followed by temporary dipoles. So if we were comparing two molecules, one of which had hydrogen bonding and one of which didn't, you would expect the one with hydrogen bonding to have higher melting and boiling points than the one without. Where things get a bit mucky is where you might have a small molecule with hydrogen bonds and a large molecule that only has temporary dipoles, because figuring out which one is going to be more significant is not necessarily that obvious. But usually you'll be given some data like the boiling point or the enthalpy of vaporization. So what you want to be able to do is relate what you know back to what you've been given. So I'm going to give you a really general structure of an answer. It is going to be quite general because it's going to depend very much on the question and the types of molecules and what's going on. There's a lot more permutations and combinations. But in general, if you start off with statements such like all molecules have temporary dipoles, this particular molecule, whatever it is, has the largest molar mass or biggest electron cloud, so will have the strongest temporary dipole forces. However, this other molecule or these other molecules will have permanent dipoles or hydrogen bonding present as well, which tend to be stronger. And then you can relate that back to the highest melting and boiling points, and which one where. Now that's still quite waffly and airy-fairy, I realise that, but it's a good starting point. So if we come back to this exam question, 2018, the way the question actually went was the first part was to list all the forces of attraction between the molecules. So we decided that both methanol and propanol had temporary dipoles, permanent dipoles, and hydrogen bonding present. Propanol had only temporary dipoles and permanent dipoles. Now, if you look at the molar mass, you can see that propanol and propanol have virtually the same molar mass, which is significantly bigger, than nearly twice as much as methanol. Okay, so compare and contrast the enthalpy of vaporization of methanol, propanol, and propanol. Your answer should include an explanation of the relative strength of the attractive forces between molecules. Okay, so here's how we're going to do that. First, we're going to compare the temporary dipoles across all three molecules. Okay, so propanol and propanol have larger electron clouds and therefore will have stronger temporary dipole forces than methanol. All molecules contain a permanent dipole. However, methanol and propanol both have hydrogen bonding, which is a stronger type of intermolecular bonding than the permanent dipoles, which are present in propanol. Therefore, you would expect methanol and propanol to have stronger intermolecular forces and then a larger enthalpy of vaporization than propanol. Because propanol has a larger electron cloud, it's going to have stronger forces again than methanol. Now that's a bit waffly still, so I will give you a written example of this. Here's how I would answer that question. All three molecules have temporary dipoles, but the propan-1-ol and propanol have larger electron clouds than methanol and will therefore form more stronger temporary dipoles. All three molecules also have permanent dipoles. Both methanol and propan-1-ol have hydrogen bonding, while propanol does not have hydrogen bonding. Hydrogen bonding is the strongest form of intermolecular bonding, which is why these two molecules have the highest enthalpy of vaporization compared to propanol. Because propan-1-ol has more temporary dipole forces than methanol, it has the highest enthalpy of vaporization. Now you might want to expand on that slightly more, but that's going to be the guts of what you would want to put in there. You've identified all three types of intermolecular bonding, you've discussed which ones are the strongest, and related that back to the structure of the molecules, and you've related that back to the enthalpy of vaporization. Okay, thanks for listening, guys, and tomorrow or in my next video I'm going to be back looking at enthalpy. See you then.